We're doing vertical and horizontal cross sections using isosceles right triangles, and we're going to sandwich them between two curves. So here we have the x squared in blue and the 2x line in red. If I am telling you this cross section is perpendicular to the y-axis, that's a horizontal cross section. So I've drawn it here in black, and you can see that the distance, the leg of this isosceles right triangle is the difference between the blue and the red curve, but you need to take the difference in the x coordinates. You see, we're measuring a distance horizontally. So we'll have to solve for these expressions, and we'll have to solve for x. I've done that over here. X squared equals y becomes x equal to square root of y. Now, remember, there are two roots when you take a square root. You have to think about which one you need. In this case, because x is on the right side, the positive x's are where we are only going to take the positive root. Very easy. Now, the 2x line, you can solve for x simply by dividing by 2. So x is y over 2. Now, we generally want to write our difference equation. We want to be careful to make the rightmost value first in the subtraction sentence. But it turns out it won't matter for us here because we're going to square S. The area of the isosceles right triangle is simply half of a square. So it's 1/2 S squared. So we'll get lucky in that we really can't make a mistake with the order of this subtraction sentence, but not all areas have this simple formula. So you want to think about which value is going to be more positive or the largest value in your subtraction sentence. Now, because we're making this a horizontal cross section, we're going to vary the y's. We're going to integrate with respect to dy. Now, dy is going to vary from 0 to 4. How do we find that? You can simply set these two expressions equal to one another and solve for the two y values. You'll get two values of y at 0 and 4. You could also do this in terms of a vertical cross section. If this was the problem statement, we would have a cross section perpendicular to the x-axis. In that case, you're subtracting the y values from the top and bottom. And now we see that it's the 2x curve that is on top. So your subtraction sentence would read 2x minus x squared. This is the length of your S, your side of the right triangle. And this is squared as well and multiply by 1/2. The formula for the area is always the same. It's the S that will differ. Your limits now will be from 0 to 2 because you need the x coordinates where these curves intersect. You're varying the x coordinate because you have an integral in terms of dx.